Welcome to the library. Yo, son.
Shit is bugging.
Hey, homie. What's going on, bro? What's good? Aha, encyclopedia. I have coffee. What are you gonna do, Dirks? Great Depression. Where's that textbook? Where's that nerd? Calculus. Calculus. Who is this nerd? You think you're smart? Huh? Huh? You think you're smart? Let's test her, right, library? Yeah. Show me how this is done, dork.
Okay, well, first, this is your f double prime of x line, okay? Then you have to find all the values. Let's call this A. You're going to find all your values from -7 to 7. Don't laugh, this is serious. Okay, you have to find all your values of x. For f. First, in order to do that, you have to take an f double prime number line, basically of this graph that you see here. In order to do that, you have to take the numbers, which are these roots, right? So here we have -5, 1, and 5.
Oh.
And you can like test numbers in between them, but because we can see that this is above the graph, we're gonna say that this is positive, and this is beneath the graph, so it's negative, above to negative to 5, +5 is positive, and then that's just where we're gonna leave it. So it just goes like that. This is like this. So this is a max. This is a min. That's a max.
Oh.
Okay?
I see you, son.
Yeah. So after we did that, this is how we're gonna find the values for a relative max. Because we see that these are peaks. Oops. You know that -5 and 5 are our values for a relative maximum.
Oh, because it carrots up, right?
Yeah.
I see you.
And then for the relative minimum, we see that this peaks down. We know that the answer is 1.
Oh, because it's a carrot down.
Correct. So if you wanted to draw the f prime, not the f prime of x graph like this, but where it came from originally, the f of x graph, we can do that on the side over here.
Yeah, I'd like to see you try that.
1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. Do you want to try and see if you can do this part?
Sure.
Or you need some more help?
We could do it together.
Okay, let's do this together, okay?
Mm-hmm.
So, if we know that these are the relative maximums, where would we put the highest points on this graph? Because the f prime of x line shows where the maxes and mins are on the f, right, on just the f of the x graph.
The roots of here are the max and mins of here,
Correct.
and the maxes and mins of here are the point of inflections on here.
That is 100% correct. Good job.
You are such a good teacher.
Thank you so much.
So let's draw that out easy.
Okay, so 1, 2, 3, 4, 5. Here's a maximum. Oops. And 1, 2, 3, 4, 5. Another maximum. Then where's the minimum?
They'll be right there.
Yeah, wait, this is negative. Sorry.
Under the -1.
Very good. So
now we gotta connect the points, right?
yeah, but don't forget that on this graph we have endpoints at -7 and 7. So there aren't arrows at the end of the thing. So,
Oh, interesting. So we got to put points there and there.
right, and see, because this is a peak, we know that this is going to end going down. So we can put a point on 7, and this one also is going to end going down. So we can put a point where 7 is also. But you have to make sure that they're not below where the relative minimum is.
Right, because that is the bottom,
Exactly.
the min.
So
Like when you hit
let's
rock
connect the
bottom.
dots, okay? Where did you say the POIs were?
The point of inflections are where concavity changes.
Right. So before we can do that, we have to do an f double prime of x line. And that are these maxes and mins, right?
Right.
So we know that we have to put a point at -3, a point at 2, and a point at...
7 and -7, because they're the endpoints.
Very good.
Brother.
So, if this is a minimum, we know that the caret's down,
Right.
and then this one would.
Carrot up.
Very good. So, that means that this is concave,
Down.
right?
That's concave up. It's concave down.
Excellent. There we go.
So now let's verify that it makes sense.
So at -3, 1, 2, 3, we can put a point right here. And here we finish the concave down, and then we start to concave up to...
Oh.
And then this goes concave up until...
The 2.
Correct.
The 2.
Which we can make a point there
Right
also.
there. Yeah, brother. Makes sense.
And then we start to concave down again to all the way to +7. And this is what our f of x graph will look like.
I see you, brother.
Okay.
So brother, you think you're that smart. I just want to confirm that
Okay.
you know. Find all the values from -7 to 7 at which f double prime of x is 0. Is less than 0.
Okay, all that really, if we want to find where f double prime of x is less than 0, all that really means is where does it concave down?
Oh, so you actually know this?
Yeah, we did this already from our f double prime of x graph. Based on what I told you before, can you tell me what intervals is where it concaves down?
Okay, between -7 and -3. And I'm gonna have to say between 2 and 7. Yeah.
Okay, one more question for you. Do you know why this is a less than sign, not a less than or equal to sign?
No, brother, tell me.
Okay, well, basically, these are the endpoints, and you can't have it equal to 7 because of where it concaves up and down. That's why. It's the points.
I see ya.
All right, cool.
And finally, for my last challenging question, at what value of x for -7, between 7, does f attain its absolute maximum?
Well, based on the graph that we drew here, we can see that these 2 points, based on our graph, are both the -3 the -5 and the +5 x values are where we have our absolute max. So
I understand now.
it's also -5 and 5. And this is true because this is the absolute values at the closed interval. If this wasn't closed for at 7 and -7, there could have been more absolute maximums. But
So
for this
it-
case, for what we drew, it would be -5 and 5.
Okay. Well, Isabel, that was absolutely riveting, challenging, moving, all the above adjectives. And I really appreciate your time and changing me as a human being, teaching me f prime of x, f double prime of x, and of course f of x. Thank you for your time, and I really hope you enjoyed this presentation. Peace!